Welcome to Two Projects. In this video, we are going to explain the project Blockchain Technology in Banking. Introduction. The project aims to explore and implement the transformative potential of blockchain technology within the banking industry, recognizing the need for innovation to address existing challenges. Traditional banking grapples with issues such as slow transactions, a lack of transparency, and susceptibility to fraud stemming from centralized systems. These challenges have a direct impact on customer service and cost efficiency, highlighting the necessity for innovative solutions. So, to address the identified challenges, the project is adopting blockchain technology. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And the project leverages Ethereum's blockchain, renowned for its capability to implement smart contracts. These smart contracts effectively manage financial data, enabling secure transactions and asset management. This approach aims to provide a fresh and improved banking experience, delivering enhanced efficiency and security. Objective of the project. So, as I mentioned earlier, the project aims to bring banking into the modern age by using blockchain. This involves making transactions faster, ensuring better privacy, maintaining data integrity, and overall making banking more efficient. By embracing blockchain technology, the project strives to upgrade traditional banking practices and create a more advanced financial system. A key focus of the project is to create a tamper proof system using blockchain. This means using special codes and decentralized storage to secure data integrity. The goal is to build a system that is resistant to tampering and disruptions, ensuring continuous access even if some parts of the system fail. This objective underscores the project's commitment to boosting the security and reliability of banking operations. And the project aims to revolutionize financial transaction management by leveraging smart contracts based on blockchain technology. Smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. They provide a secure and efficient method for handling financial processes, ensuring transparency and reliability in agreements. Requirements needed to execute this project are software requirements. Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Flask. Front-end languages used are HTML, CSS, JS, and Bootstrap 4. Hardware requirements needed are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So to execute this project, we have designed few modules. First, we'll discuss the user modules. The first one is user sign up. So users initiate their journey by signing up, providing necessary information such as username, password, and other required details. This step establishes a unique user account within the system. The second module is user login. Here, registered users log in using their credentials. This module ensures secure access to user specific functionalities and data. The third module is deposit amount. In this module, users have the capability to deposit funds into their accounts. This involves specifying the amount they wish to deposit, and the system updates the user's account balance accordingly. The next module is send request for transaction. Here, users can initiate transaction requests to other users. The recipient user receives a notification and has the option to accept or reject the transaction. If accepted, an OTP, that is one time password verification process, is triggered to enhance security. The next module is view request. Here, users can monitor the status of transaction requests they have received from others. This module provides visibility into pending and accepted transactions. The next one is send amount. In this module, users can authorize the transfer of funds to another user. This involves specifying the recipient's details and the amount to be sent. The transaction undergoes OTP verification for added security. The next module is view balance. Here, users can check their account balance at any time. This module provides real time information on the remaining funds in the user's account. Now we'll see the admin modules. The first one is admin login. So, admins access the system through a secure login. This module ensures that only authorized personnel can access administrative functionalities. And the last module is view transactions. In this module, admins have the ability to view all transactions within the system. This includes details such as transaction amounts, sender and receiver information, timestamps, and transaction statuses. This module aids in monitoring and managing overall system activity. Blockchain integration. So, blockchain is employed to enhance transaction security by storing financial data and user login details in tamper proof blocks. Each financial transaction, such as depositing an amount or sending funds, is recorded as a block on the blockchain. These blocks are secured with unique hash codes, providing an extra layer of security. Once a block is added to the blockchain, it becomes immutable, meaning that the data within it cannot be altered or tampered with. This ensures the integrity and security of the entire transaction history. And all transactions are stored in a decentralized and distributed format across multiple network nodes. This decentralized storage eliminates the reliance on a single centralized server. Instead, the transaction data is distributed across a network of nodes, enhancing data resilience. In case one node fails or is compromised, the data remains accessible and secure through the redundancy of the decentralized network. And smart contracts on the blockchain are leveraged to manage financial transactions efficiently and securely. These contracts execute predefined rules when specific conditions are met. For instance, when a user initiates a transaction request, a smart contract governs the terms and conditions of the transaction. If the recipient accepts the request, the smart contract triggers additional processes such as an OTP verification, ensuring the integrity and secure execution of the transaction. This enhances the overall operational reliability of financial processes. And every transaction recorded on the blockchain is visible to authorized participants, ensuring transparency. This transparency allows users and administrators to view and verify transaction details easily. The entire transaction history is accessible and cannot be altered, providing a transparent and verifiable record. And we have used Ganache in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information including sender, receiver, amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification processes. And Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. Ganache also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. And we have used MetaMask in this project. So, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. And in this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. This transparency maintains accuracy and ensures confident, reliable financial interactions within the system. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is contracts folder in which I have Solidity files. They handle data structures, functions, and events with modifiers for validation. This is static folder. It consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And this is run.bat file to start the banking system. So before running the run.bat file, we have to host the Ganache server. For that, open Ganache. So we can see the server has been hosted. Now we'll get back to the code folder. Now double click on run.bat file to start banking system. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. So the Flask framework will host the application locally at the default address, local host and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see user login, admin login, and user sign up links. So if you are new users, we have to register first. Click on user sign up link. We have to fill in all these details and click on register button to sign up. So username would be Ramesh. Give the password. Give the contact number. Give the email ID. Give the address. Select the gender from the drop down and click on register button. So here in the red color text, we can see sign up process completed and record saved in blockchain. So all these user details will be stored in blockchain in a form of block. We can see that in Ganache. So we can see a block has been created in which all these registration details, the user details will be stored. So we can retrieve the data from here. Minimize this and in MetaMask, click on the Chrome extension. We have to give the password here. So we can see I have a balance of 99.9834 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. So in the context of a blockchain, transactions refer to the actions or operations that are recorded on the blockchain ledger. So now we'll create another account. Click on user sign up link. This time username would be Ram. Give the password. Give the contact number. Give the email ID. Give the address. Select the gender and click on register button. So we can see sign up process completed. So all these details will be stored in blockchain. Now we'll log in, click on user login link. So first we'll log in as Ramesh, give the credentials, username and password of Ramesh and click on login button. So we have logged in as Ramesh and here we can see deposit amount, send request for transaction, view request, send amount, view balance and logout links. So first click on view balance link. So we can see the current balance is 0. So first we'll deposit money. For that click on deposit amount link. So we'll self deposit. So the username is Ramesh, amount would be 10,000 and click on submit button. So we can see money added to user account Ramesh. So all these transaction details will also be saved to blockchain. Click on view balance link. So now here we can see current balance is 10,000. We can see the transaction status, that is self deposit. We can see the transaction date and time. Now click on send request for transaction link. So here we can send transaction request to other users. If that person, that is the recipient, accepts the request, only then we can make transactions. So we have to select the receiver name here from the drop down. I'm giving it as Ram and click on send request button. So we can see request sent successfully. Click on view request link. So here we can see the list of transaction requests received. We can see there are no requests yet. Click on send amount link. So here we can transfer the amount to other accounts. So username is Ramesh, available balance in the account is 10,000. We have to select the receiver name here from the drop down. We have to give the amount and we have to enter the OTP. But we haven't received any OTP yet. So for that, the recipient must first accept a transaction request. So click on logout. Now we'll log in as Ram. Click on user login link. Give the credentials, username and password of Ram and click on login button. So we have logged in as Ram. Click on view request link. So here we can see the transaction request sent by Ramesh. We can see date and time and we can see a click here to accept link. By clicking on it, we can accept the transaction request. So I'm clicking on click here to accept link. So the transaction request has been accepted and OTP sent successfully. So the OTP sent to the mail of Ramesh. So now click on view request link. So here we can see the status has been changed, that is already accepted. Now click on logout. Now we log in as Ramesh. Click on user login link. Give the credentials of Ramesh and click on login button. Click on send amount link. So amount would be 5,000 and OTP sent to our mails. So this is the OTP sent. Copy it, paste it here. Now click on submit button. So the OTP verification is successful and here we can see money sent to Ram. Now click on view balance link. So here we can see the transaction history, that is username Ramesh have self deposited, the amount is 10,000 and later Ramesh has sent to Ram, the amount is 5,000 and the current balance available in the account is 5,000. We can see the transaction date and time also. Now click on logout. We'll log in as Ram. Click on user login link. Give the credentials of Ram. Click on login. Click on view balance link. So here we can see the current available balance, that is 5,000 and it is received from Ramesh. So here we can see the transaction status, that is received from Ramesh. So all these transaction details will be stored in blockchain in a form of block. We can see that in Ganache. So we can see blocks are being created for all these transactions. And minimize this. Click on logout. Now we log in as admin. Click on admin login link. So admin here would be a bank. So give the credentials, username and password of admin and click on login button. So we have logged in as admin and here we can see view transactions and logout links. Click on view transactions link. So here admin can view all the transaction history, the username, amount, transaction date and time, and the transaction status. So we can see Ramesh has self-deposited, the amount was 10,000 and Ramesh has sent the amount to Ram, the amount was 5,000 and Ramesh has received from Ramesh, the amount was 5,000. Now click on logout. So all the transaction details and registration details will be stored in the blockchain as blocks and can be retrieved from there. So we can see that through Ganesh. So now click on any block. So here we can see block hash, the transaction hash. Click on transaction hash. So here we can see sender address, to contract address, gas used, gas price, gas limit, and the transaction data. So now minimize this. And in MetaMask, so we can see ETH balance remains unchanged after each block creation because the project's actions don't involve significant ETH transfers. So this is normal as not all operations lead to substantial balance changes. So the conclusion here is the project successfully integrated blockchain technology into the banking system, transforming traditional financial processes. The adoption of blockchain ensured enhanced security, transparency, and reliability in transactions. And the project met its objectives of modernizing banking operations. Through the implementation of blockchain, the system achieved faster transactions, improved privacy, data integrity, and overall efficiency, aligning with the project's goals. Users in the system itself have emerged as beneficiaries of the project. Users experience secure transactions, decentralized authentication, and a transparent view of their financial activities. The system benefits from improved resilience, reliability, and a tamper proof transaction history. And the utilization of smart contracts on the blockchain significantly contributed to operational efficiency. Secure management of financial transactions through smart contracts enhanced the overall reliability of banking processes. So, with the successful integration of blockchain technology, the project positions the banking system for the future. The use of tamper proof blocks, decentralized authentication, and transparent transaction history reflects a forward thinking approach that aligns with the evolving landscape of financial technology.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.